Welcome back, guys. Today we'll continue our work with different kind of statistical tools that are present in ArcMap. Today's tool is cluster and outlier analysis in JS, also commonly known as Anselin local Moran's first. It's a statistical method used to identify special patterns of similarity or difference within a dataset. It reveals areas where values are clustered, for example, groups of high or low values, or where unexpected outliers occur, for example, high values surrounded by low values. For instance, it can detect clusters of high-income neighborhoods, high, or pinpoint outliers like low crime areas with a high crime region, low-high. This tool is essential for exploring the spatial relationships between the data points and uncovering significant trends. Applications of cluster and outlier analysis are vast, including urban planning, public health, crime analysis, and environmental monitoring. For example, urban planners can use it to identify areas of concentrated poverty or economic outliers, while public health officials can map disease outbreaks or unusual infection patterns. The analysis is accessible through tools like ArcGIS Special Statistical Toolbox, QGIS plugins, and Python libraries such as PyCell and SPDEP, making it a powerful resource for spatial data analysis and informed decision making. So this is a map we will be working today. First, let's take a brief look. This is our region, Battalion 2. This is a population for 2010 for this region. So see that this areas, darker areas, have a higher density, and these areas have a lower density population. And these are our active station, and these are the calls for February 15. Imagine that we have a scenario. The fire chief needs a map that shows the results for the next city council meeting. The chief also wants to show hot spots and cold spots based on future locations and the ranking of the calls. Then the chief can overlay the data on the census data to see if there is some type of relationship between the two datasets. So let's go to search and search. So I think this one, yes. So see that when it's statistical tool, it shows like this. So it's called also Anselin local Morans. Given a set of weighted features, identify statistically significant hotspots, cold spots, and spatial outliers using the Anselin local Morans. So this is the input. So local index, z-scores, p-values, and cluster type. So input feature is February 15 calls. Input field, it's so we have this field named FEE, which shows the priority of a call. The highest priority has the calls which are related to human health. A moderate priority has the calls which are related to damage to physical property, and lowest priority has the calls which are fake calls, doesn't relate to anything. So let's say it. So conceptualization. So we will put it to fix a distance band. Each feature is analyzed within the context of the neighborhood features. Neighboring features inside a specific critical distance receive a weight of 1 and exert influence on computation for the target feature. Neighboring features outside the critical distance receive a weight of 0 and have no influence on target features computations. So it's fixed distance, Euclidean distance. So here distance method specifies how distances are calculated from each feature to neighboring features. So Euclidean distance, you might know that this Euclidean distance, what does it mean? The straight line distance between 2 points. Second is Manhattan distance, the distance between 2 points measured along axis at right angle. CT below calculated by summing the absolute difference between the x and y coordinates. So we'll choose Euclidean distance standardization. So row standardization is recommended whenever the distribution of your features is potentially biased due to the sampling design or an imposed aggregation scheme. So we will leave it none, and distance band or threshold distance, we'll put it 900 feet. So it specifies a cutoff distance for inverse distance and fixed distance options. Features outside the specified cutoff for a target feature are ignored in analysis for that feature. However, for zone of indifference, the influence of features outside the given distance is reduced with distances. So number of permutations 499. So let's click OK. Yes, this is the result. By the way, do not forget to put these permutations to 0 or 99, otherwise your computer might be stuck and have a mistake. I accidentally put it to 499, which it's actually default 499, but not all computers can have this computation capacity, so it's better to put to 0 or 99, but better 99 if you want to have high accuracy. So number of random permutations for the calculation of pseudo p-value. The default number of permutations 499. If you choose one permutation, the standard p-value is calculated, the standard p-value. So 0 permutations are not used and the standard p-value is calculated. 99 permutations, the smallest possible pseudo p-value is 0.01, and all the pseudo p-values will be even multiple of this value, etc. So this is my map. So see that these are the hotspots. We can open attribute table. Here there are several attributes here. First let's discuss this one, LMIZ score. So shows the statistical significance of the clustering as described earlier, and this value is the probability of error in rejected null hypothesis. So the cope type field distinguished between the statistically significant 0.05 cluster of high values, cluster of low values, and outlier high values surrounded primarily by low values, and outlier low values surrounded by primarily high values. So this is low values surrounded by high values. This is low values surrounded by low values, high values surrounded by high values. And HL is high values surrounded by primarily low values. So this one. And this one, the element index indicates whether the feature has other features of similar value near it. So we can go to symbology and change slightly a little bit the symbology, make it bigger. Quantities, wait, so it's categories. So properties of all symbols. Let's make it bigger. So see, these are the hotspots: high cluster. This violet one, where is it? Probably zoom. Yeah, here is it. High low values. Let's also make this layer, put transparency to 40%. So let's turn on this calls for services. So these are the hotspots with high hotspots, this red one and this color with higher values, and these are the cold spots with lower values, and these are non-significant calls. If we compare it with the population, we cannot say that there is a distinct correlation. So both high and low value calls can be located in low density population and in higher density population as well. So see that there is no significant match between these two layers, between our clustering analysis and the census data. So where also this kind of clustering can be used? For instance, an oil well drilling company may look at the clustering of high output values to site new wells. Areas with clustering of low values might be avoided. Another example is a testing agency might look for clustering of high school test scores within the school district to find schools that excel or schools that do poorly, to see if there is an association between the area and the source scores.